Hello, my name is Alan Hepburn and I am the Chief of the East Canada Tribe of the International Comanche Society. This presentation will show you how you can replace all of your 1960s vintage engine instrumentation with 21st century equipment. The specific airplane we'll be discussing is a Twin Comanche, but most of the information is applicable to the single Comanche and to many other types. On the Twin, there's a data acquisition module installed in each nacelle. This eliminates a lot of wiring and tubing running from the nacelles to the instrument panel through the wing root ducts. On the single, the data acquisition unit would be mounted behind the firewall. The various pressure sensors for the single can be installed in the engine compartment. Here is what the original engine instrument panel looks like. Typically, there were individual tachometers, a pair of two-pointer instruments for manifold pressure and fuel flow, and a set of cluster gauges for oil temperature, oil pressure, fuel quantities, and cylinder head temperatures. It's getting difficult to find sensors that match some of these cluster gauges. The tack cables are prone to failure and are bare to replace. There's only one fuel quantity gauge per wing, yet on my airplane there are 3 tanks in each wing. The gauges are connected to the tanks you're using by some micro switches under the floor near the fuel selectors, and these get out of adjustment, leaving the gauge open circuit and showing empty. On my airplane, the original fuel flow gauge, which is actually a pressure gauge connected to the fuel spider on top of the engine, had been replaced by a Shaden Digiflow fuel totalizer, which was approved for primary use. When I went shopping for an electronic replacement system, I wanted to add an engine analyzer display for both engines. There were a few analyzers designed specifically for twins, but they were fairly pricey, so I started looking at single engine analyzers with the idea of having one for each engine. I also wanted a colour display, since the earlier orange displays were already beginning to look dated. The Electronics International CGR30P looked like it met my needs. It's certified as primary replacement for all the original instruments. There is no room on the CGR30Ps for fuel quantities. For these, I use a single CGR30C cluster gauge. It has 2 columns of horizontal bars, plus a couple of digital-only displays at the bottom, and some annunciators at the top. You can replace the top 2 bars with arcs for RPM and manifold pressure, just like the 30P. I've used 2 of these on a friend's Twin Comanche, where he already had a JPI twin-engine analyzer installed. Each side displays RPM, manifold pressure as arcs, oil temperature and pressure, and main and auxiliary fuel quantities as bars, and alternator output and voltage as digital displays. They custom program the details to suit your specific aircraft. The data is acquired in each nacelle by a data acquisition module, an EDC33, and sent to the panel by a single wire on each side. They supply all the sensors. One of the options worth considering is an alternator shunt, so you can display the output of each alternator. Another is magnetic fuel quantity senders to replace the original resistive units. If you don't go for the magnetic senders, you'll need an RF-ML module in each nacelle, which adapts your resistive senders to the EDC33 inputs. Finally, they have a digital fuel flow totalizer, but it is not certified for primary. Here's what the finished result looks like. The obvious layout would be to have the CGR30Ps for the left and right engines laid out side by side, but I decided to mount them above each other because you have to be able to reach over to enter data on the ground and in flight. The totalizers allow you to keep track of how much fuel is in each tank, but you have to remember to adjust the quantity remaining when you top up the tanks and to change the tank selected flag when you change tanks. I had them add a tick on my tanks at 2400 RPM, my normal operating point, and ticks every 5 inches of manifold pressure. The fuel flow you see is driven by the digital fuel flow totalizer. I still have to have a certified fuel flow measurement. It's on a separate page where I never look at it and is calibrated in pounds per square inch. The CGR30C cluster gauge accommodates all 6 fuel quantities and has one additional bar on each side, which I decided to use to display the output of each alternator, plus a couple of digital displays which I used for system voltage and flight time. I didn't go for the magnetic fuel quantity senders, as I just had my resistive ones overhauled, but I have installed them on a friend's airplane and they work very well. You have to send the old resistive units back to the factory so they can match them physically. They do need one extra wire. For the mains and auxiliaries that is easy, but for the tips you will need to fish the extra wire out to the tip somehow. You'll see that I added an annunciator on the 30C to show when the heater is turned on. There are also annunciators which indicate when the tip tanks are selected and when the fuel pumps are running. You have to admit it's a lot cleaner than the original. In the bottom right corner there's a separate sub-panel that houses the ELT controls and EI's USB 6A, which has USB outputs for dumping the engine data plus a couple of ports for charging iPads and so forth. This can be easily removed to service the ELT controller batteries. On the pilot's panel there are 2 pairs of red and yellow LEDs. When any parameter on a CGR30P goes into the yellow arc, the corresponding yellow light comes on. When any crosses the red line, that lights up the red light. As you can see, there's also a dimmer for the EI instruments. While it might be possible to use the existing panel, you'll get a much nicer job if you get a new one from Ron and John's Comanche service. It comes with an STC. The price is particularly attractive if you have already replaced the left panel. You just send them a drawing of the cutouts you want. The EI instruments come with an STC, generic installation instructions, and wiring diagrams for their equipment. The instruments are configured per your order, but there are no installation instructions or wiring diagrams for any specific airplane type. You pretty well have to prepare a set of aircraft-specific wiring diagrams. I marked up the original Piper drawings. There are a number of existing wires that can be repurposed, the blue ones here, avoiding the need to fish new wires through the wing root ducts. For example, the existing cylinder and oil temperature breaker is no longer required. It can be picked up behind the cluster gauges on wire Q2A and used to supply the right CGR30P. Then the right fuel gauge ground wire Q4D can be used to take 12 volt to the right nacelle. For the left CGR30P, you can pick up the fuel gauge breaker behind the cluster gauges on wire Q1A and extend it to the left nacelle using wire Q3D. You also need data wires to the left and right nacelles. The cylinder head temperature wires E1A and E2A can be used for this. If you want the fuel pumps to be enunciated, you will need to take wires from the fuel pump switches to the EDC33s in the nacelles. You can use the old oil temperature wires Q2B and Q2C for this. I fished a new wire from the heater switch to the right EDC for the heater enunciation. Now to the installation. You can install the EDC, the RFML, the new oil and manifold pressure sensors, and the alternator shunts in the compartments behind the firewalls. I used riv nuts through the rear bulkhead, so you'll need a riv nut puller. The airplane is still flyable up to this point, but from here on you're grounded. In the cabin, remove the plastic instrument panel overlay, then the tacks, manifold pressure gauges, fuel flow pressure gauge, and the cluster gauges, and trim the panel with tin snips to leave 5/8 all round, to which the new panel will eventually be bolted per Ron and John's instructions. You now strip out all the plumbing for the old pressure instruments and the tack drive cables. That leaves quite a pile of tubing on the hangar floor. There are a few holes in the firewall that have to be patched. Some of the patches here cover penetrations for vacuum lines, which were removed when I got rid of my instrument vacuum system. You next replace the sensors in the engine compartment. The oil temperature probe replaces the original. The EGT probes are added to the exhausts as usual. The cylinder head temperature probes go into the threaded wells on each cylinder. The tack drives are removed and blanked off with caps supplied by EI. The only disappointment was that the original fuel pressure impulse lines, which come from the fuel spider on top of the engine and eventually wind up at the cluster gauge, had to be removed because the shading unit did not need them. Since I now needed to restore the fuel pressure measurement to be legal, I had to replace this plumbing as far as the firewall. Some of the parts were unusual, but I eventually got them from Webco. Add the fuel pressure sensors, then connect all the pressure sensors to the fittings that carry the impulse lines through the firewall. The fuel flow sensors are at the bottom of the nacelles, where they replace my shading ones. If your airplane has no sensors here, you will have to add supports for them. Now for the wiring. The EDC comes with plugs that have about 60 inches of wire attached, which you trim to length and attach to the pigtails on the sensors using butt splices unique to EI. I've had some trouble with these. They need to be well supported with tie wraps, and the design has changed recently to one with 2 grub screws per connector. There is one special tool you may need, a crimper for the pins on the D-sub connectors. You should also have an aviation crimp tool for standard pink butt splices and ring terminals. The alternator shunt is connected to the EDC via fuses. RPM is sensed via wires taken from the end of the filters that pass the magnetopelids through the firewall to the EDC via resistors supplied by EI. There is an existing terminal block in each nacelle. You can pick up the main and auxiliary fuel level sensors at these blocks. The wires are Q3B and Q6B on the left side, and Q4B and Q7B on the right side. The tip tanks are a bit more complicated. I won't go into details here. There are some unused terminals on these blocks which you can use for things like the 12 volt coming from the panel, but they may have been used by other retrofit equipment, so I won't go into detail on these either. The ground wires from the main and auxiliary fuel level sensors Q6C and D and Q7C and D are removed from the terminal blocks and are grounded at the bulkhead, along with the grounds for the EDCs and RFMLs. This is why you need to prepare a wiring diagram. In the cabin, you need to install the warning LEDs on the pilot side, then complete the wiring of the EI instruments, install the Ron and John's panel, and mount the EI instruments to it. Leaving the panel installation to this point makes the wiring behind the panel easier. Now it's time for the most laborious part of the job, calibrating the fuel gauges. Starting with empty tanks, you add gas in 5-gallon increments, registering the calibration point at each step until the tanks are full. The EI instructions give the details. That's about it. Run up the engines, check for leaks, and make sure the readings make sense. Then complete the paperwork.